Hello guys, my name is Sajid Ibrahimi, and this is the presentation regarding to our simulation class. The project is about simulation of a cladding plant, and actually the cladding process is a process in which one material, for example, in our process, the steel will be sandwiched by the other material, which is copper. Okay. In this project, our entity will be orders which will arrive to our system with an exponential distribution. About our processes, we'll have two kinds of resources. The first one is our machines, which consist of shot blasting, cleaning, bonding, annealing, and so on. And we'll have workers which are allocated to our different machines. And the workers will be working in 3 shifts. Okay. And about our flowchart. Okay. At the first time, the steel coil will be shot blasted, and at the same time, our copper coil will be cleaned. And then they will go to the next process, which is bonding. In the bonding, the steel will be a layer of steel will be sandwiched by 2 layers of copper. And when the process is done, we'll go to the next process, which is annealing. In annealing, our product will be heated and it will help it to actually strengthen our alloy. And then we'll go to the cleaning process to cut some impurities, and when the process is done, we'll go to the slitting because after all these processes, we'll have cracks on the edges of our products. So by the slitting process, we'll cut that cracks. And then we'll go to the rolling process. In the rolling process, we tend to decrease the thickness of our product. And when the process is done, we'll go again to the annealing process. At this time, we tend to relieve the stress in our products. As soon as the process is done, we'll again go to the cleaning line. And when our product is cleaned, we'll go again to the rolling process. And in the rolling process, our product will be converted to our desired gauges. And when this process is done, again we'll go to the cleaning, and then we'll go to the slitting. And at this time, we'll have our products in our desired measurements. And when the process is done, we'll go to the packaging part, and our product will be distributed to our customers.
Okay, my friend told you about the model till now, and now I'll take you to the arena model. And as you can see on the screen, these are our assumptions. We have only considered one product. The company manufactures various products, but to simplify the model, we have only considered one of the product. We have not considered the in-depth modeling of the process is not considered. Then width changes are ignored to reduce the complexity. Line speeds are defined as distributions, and coil weights are is equal to order weights. And workers are shared for the packing station. We have defined workers at different stations, but for packing we have shared the workers. Now coming to the model, here we have different stations. As you can see, here we have the order release station, we have coil release station, shot blasting, bonding, annealing, cleaning, slitting, rolling, packing. Okay, so the order release station is the station where the orders are generated. We have put a distribution for that. And the next you can see the assign module. This assign module act as which converts the order weight into its length, and it also assigns the order ID to the order generated. Now, as you can see, this coil release module, this act as a warehouse where the coils are being generated, means where the order is converted into coils, and as soon as the coils are generated, this separate module helps us to generate 2 copper coils and 1 of the steel coil, and the copper coil goes to the cleaning. Copper coil goes to the cleaning line right here. 2 copper coils that are generated goes to the cleaning line, and 1 of the steel coil goes to the short blasting line. As soon as they are processed here, they come to the bonding mill where they are batched together with this batch module. This batch module makes a permanent batch, which, as you can see, and order ID again comes together to make the batch possible. Without the order ID, the batch won't be possible. So this order ID is very important here, and as soon as it goes further, the bonding process is done. Again, it comes to annealing, where again we have used a batch process, but here, in terms of, as this was a permanent batch, this becomes a temporary batch here, and this batch is again, after the processing, it again gets separated from using the separate module, and then the process moves further. After annealing, the coil goes to the cleaning line, and as my friend told you, all the process, it goes accordingly. Then we have also used the transporters for the transportation of coils. We have also used different schedules, which helps us in movement of the coil from one station to the other. And now I'll take you to the different schedules. I'll show you how they work. So here for the steel coil, we have a short blasting station and bonding station. Similarly for copper goes for cleaning and bonding, and bonded coil goes to all these stations, and the combination of all these stations are defined here in a sequence set. And that's it for now, and my friend will explain you about the analysis part, and thank you.
So far, my friend mentioned how we developed our simulation model. Before any further progress, we're interested to do some data analysis. The first step, we checked our model's result to see when it comes to the steady state. As you see in these pictures, we considered 2 different measures: utilization in shot blasting station and the process time, mean process time of the entities. And as you see in this picture, after 25 or 30 days, our simulation model come to the steady state, but we considered the whole year to decrease the effect of on a steady state. To define the necessary number of replication, we use half-width methods. In the first step, we run our model for 3 replication, and we calculated the standard deviation and the mean, and we comes to the conclusion that 8 number of replication is good. So in second step, we run our model for the 8th replication, and we saw that by increasing the number of replication, the variance of the model will decrease, and we reach to the steady state in a shorter period. Totally, we consider 100 replication during our analysis. So to validate our model, we considered the number of orders per year. In our null hypothesis, we considered 232 orders. After 100 replication, we reached to 95 confidence interval, which is between 231 and 232, which does not rejected our null hypothesis. Also, we checked the lead time, which means the time that takes to prepare an order. We used the read and write modules, and we saved it in Excel, and we did the calculation to calculate the upper bound and lower bound, and you see that the 5 days average of lead time is in between lower bound and upper bound, so we cannot reject our null hypothesis. So with these steps we validated our models. Imagine that we are going to buy a new facility. To do this, we considered 7 different scenarios. The first one is the initial, which is the current situation in the company. The second one is buying a new annealing furnace. The third one is buying a bundling furnace. The fourth one is buying a cleaning line, and the rest. We run our model for 100 times with these different scenarios in Process Analyzer, and as you see, all the results are the same. That's why our system is unutilized. So you see, most of the resources in our model are utilized less than 20%. So it shows that our system is ready to get more orders, and buying a new facility is not necessary. One of the interesting subjects is finding a best parking place when our transporter is idle. We considered different scenarios and run it and compare them in the output analyzer, and as you see, a slitting station has less waiting time, considering the waiting time in different leaves modules. Also, we use the other option which is available in output analyzer to analyze and do one-way ANOVA, and we got the same result. As you see, it draws a plot which is a box plot, and we see that a slitting station is the best station to park our transporter whenever it's idle. Thank you everyone for listening to our presentation.